Household energy generation systems are commonly perceived as requiring specialized electrical engineering knowledge for safe and functional implementation. This perception operates as a barrier independent of actual technical complexity. Surveys of homeowners interested in alternative energy consistently show that perceived technical inadequacy ranks among the top 3 factors preventing adoption, alongside capital cost and uncertainty about effectiveness. The perception has historical roots. Early residential electrical systems in the 1920s to 1940s did require specialized knowledge for installation and maintenance. Electrical codes developed during this period established professional licensing requirements reflecting genuine safety concerns around high-voltage systems, improper grounding, and fire hazards. These frameworks persist in contemporary code structures even as technologies and safety mechanisms have evolved. A distinction exists between inherent technical complexity and structural inaccessibility. Inherent complexity refers to systems requiring advanced mathematical knowledge, precision engineering, or specialized diagnostic equipment for implementation. Structural inaccessibility describes systems where technical barriers result from proprietary designs, restricted documentation, or deliberate obfuscation rather than fundamental difficulty. Many contemporary household energy systems fall into the second category. The underlying physical principles, electromagnetic induction, photovoltaic conversion, chemical storage, operate according to well-documented physics accessible to non-specialists. However, commercial products often implement these principles through proprietary configurations, undocumented control systems, or integration requirements that necessitate professional installation despite straightforward underlying mechanisms. This creates a perception gap. Individuals assume technical requirements match professional installation norms when, in many cases, the professional requirement stems from liability frameworks, warranty conditions, and business models rather than irreducible technical complexity. I'm James Sullivan. Let's examine how non-specialists typically approach energy system implementation. Individuals interested in DIY energy systems commonly begin by seeking formal education, community college courses in electrical systems, online certificate programs in renewable energy technology, or continuing education workshops. These programs typically span 6 to 24 months and cost $500 to $5,000, depending on format and institution. The curriculum covers electrical theory, code compliance, safety protocols, and system design principles. Another approach involves hiring consultants for system design while attempting self-installation. Engineers or energy system designers create specifications, component lists, and wiring diagrams for $1,000 to $3,000. The homeowner then purchases components and follows provided documentation for physical installation. This approach reduces labor costs while maintaining professional design oversight. Kit-based systems represent a third pathway. Manufacturers provide pre-configured component packages with simplified installation instructions designed for non-specialist implementation. Solar panel kits, small wind turbine packages, and battery storage systems in this category include mounting hardware, pre-terminated wiring, and step-by-step guides. These products trade customization for accessibility, offering standardized configurations that fit common residential scenarios. Online communities and documentation repositories provide another resource. Forums, video tutorials, and open-source design files allow individuals to learn from others who have completed similar projects. These resources document both successes and failures, providing practical knowledge that formal education often omits. However, information quality varies significantly, and determining reliable sources from unreliable ones requires existing baseline knowledge. Each approach attempts to bridge the perceived knowledge gap through structured learning, professional guidance, simplified products, or community knowledge. All assume substantial time investment, ongoing learning commitment, or acceptance of constrained options compared to custom professional installations. Formal education programs deliver electrical theory comprehensively, but often exceed requirements for specific DIY applications. A homeowner
See,
installing a small-scale
sometimes the
generation
answer is
system
just that
may not
simple.
need to calculate three-phase load
Sometimes we just have to
balancing
clear the
or
clutter to
design
find it.
commercial distribution panels. The comprehensive curriculum addresses broad professional competency rather than focused implementation knowledge for particular systems. The time and cost investment remains substantial regardless of actual knowledge requirements for the intended project.
I'm not sure if this is the right
Consultant-guided
wire.
self-installation
I
encounters
don't know what that
coordination
just said.
challenges. Design specifications assume certain implementation
Damn it, not
capabilities,
again.
proper wire termination techniques,
This isn't
weatherproof
moving.
enclosure sealing,
Guess I'll have to get the
grounding
ladder.
system installation. When self-installers lack these specific skills, they face mid-project learning requirements not anticipated in the design phase. The consultant relationship typically concludes with design delivery leaving troubleshooting and modification decisions to the installer without ongoing support. Kit-based systems simplify installation but constrain configuration options. A solar panel kit designed for 3 kilowatt capacity cannot easily scale to 5 kilowatts if household needs change. The standardization that enables non-specialist installation also limits adaptability. Additionally, kits optimize for common scenarios: south-facing roofs with specific angles, locations without significant shading. Properties outside these parameters encounter complications the simplified instructions do not address. Online community resources provide valuable
I
practical
completely
knowledge
disagree with
but
you.
lack systematic
The evidence
organization.
clearly shows
A specific
otherwise.
You are
implementation
both
question might
missing the
require
main
searching
issue
through
here.
hundreds of forum posts
Oh my
across
God.
multiple years to
What are
find
you
relevant
doing?
responses. Video tutorials vary in technical
That's it, it's
accuracy,
over.
From
some
this simple
produced by
sketch, we
qualified
developed the
individuals,
complex
others by
architecture you see
enthusiasts,
detailed on the
documenting
screen.
their first
It proves that
attempts.
great ideas can start anywhere.
Distinguishing authoritative sources from well-intentioned but flawed information requires judgment that develops only through experience. The fundamental constraint is that all these approaches assume the knowledge barrier is real and must be overcome through substantial investment. They do not question whether the barrier exists at the level commonly perceived or whether alternative system designs might eliminate rather than bridge the gap. A category of energy system designs exists that separates inherent technical complexity from implementation accessibility. These formats operate on documented physical principles but utilize configurations and component arrangements that reduce installation requirements to procedures achievable with basic electrical familiarity, understanding circuit polarity, proper wire gauge selection, and standard connection methods. This category includes systems designed around modular components with standardized interfaces, eliminating custom integration work. Plug-and-play solar microinverters that connect panels to household circuits without designing distribution systems. Battery storage units with integrated charge controllers that require only input and output connections. Small-scale generation devices with pre-wired terminals marked for specific connection types. Another subset involves historically documented designs that predate modern proprietary complexity. Electromagnetic devices. Based on century-old patent specifications, simple DC motor generator combinations, and mechanical energy conversion systems documented in technical literature from pre-commercial electrification eras. These designs existed when household electrical work was commonly performed by property owners rather than licensed contractors. The category is characterized by high documentation availability. Detailed assembly instructions, component sourcing guides, wiring diagrams, and troubleshooting protocols exist in public domain publications, online repositories, or direct purchase documentation packages. The knowledge is accessible rather than gate-kept. Implementation of these formats typically requires tools and skills common to general household maintenance: wire stripping, screw terminals, basic voltage testing. The distinction from professional installation systems is not lower performance capability, but rather design choices that prioritize implementation accessibility alongside functional requirements. One format within this accessible design category involves electromagnetic generation devices based on specific coil winding patterns and geometric configurations documented in historical patents and contemporary technical guides. These devices are typically distributed as documentation packages, assembly instructions, wiring diagrams, component specifications, and sourcing information, rather than as assembled products. Implementation involves purchasing components from general electronic suppliers based on provided specifications, assembling coil structures according to documented procedures, and connecting the completed device to household electrical systems through standard wiring methods. The documentation format allows review of complete assembly processes before component purchase, enabling assessment of required skills and tools. The devices operate continuously once installed and connected, requiring no programming, calibration, or operational interface beyond standard. Electrical connections. Maintenance consists of periodic visual inspection rather than technical diagnostics or component adjustment. This format represents one design approach among multiple pathways to household energy generation. Its appropriateness depends on individual comfort with electrical work at the household circuit level, availability of necessary tools, and access to component suppliers. The distinction between inherent complexity and structural inaccessibility applies variably across different system types and designs. Some energy generation approaches genuinely require advanced technical knowledge for safe implementation. Others become accessible when design prioritizes implementation simplicity alongside performance requirements. The perception that all household energy systems require professional-level expertise reflects historical norms and contemporary commercial practices rather than universal technical necessity across all possible system configurations. Documentation-based distribution formats exist alongside product-based commercial systems, representing different implementation pathways with different skill requirements, cost structures, and support mechanisms.